Hey, I have to present my results in lab meeting this afternoon. How do we analyze whether a burn and an infection is worse than either one alone?
That just sounds like a two-way ANOVA.
A two-way what?
I have a few minutes, so walk me through what you're doing.
Well, we're looking at a model of polytrauma, which is the idea that two forms of injury together are worse than one alone.
Isn't that kind of obvious?
Superficially, yes, but the point here is that we want to know whether the biological mechanisms are different when the two injuries occur together, or whether the body responds the same as if it was just each separately but occurring together. Does that make sense?
Of course, it sounds like you're interested in the interaction effect.
Which is.
Oh, an interaction effect occurs when the outcome of factors combined is not simply the additive effect of the factors separately. What were your conditions again?
Burn and infection.
Wow.
Yeah, it's rough, but that's why I want to make sure we do the analysis correctly, so we can use as few animals as possible and still answer our questions.
Okay, well, to test an interaction effect in a two-way analysis of variance, or two-way ANOVA for short, you need two separate factors. In this case, the factors are burn and infection, so you should have four conditions. No burn and no infection, burn without infection, no burn with infection, and both burn and infection.
That's what we have.
Great! This is called a factorial design because you have every combination of, in this case, two factors. So the idea is that if the effects of burn versus control plus the effects of infection versus control is different than the outcome of burn plus infection versus control, the two factors interact. It's not as simple as one factor plus the other.
Awesome. That's the question we're trying to answer.
Alright, well, we can get a preliminary look at your data. Of course, we'll want to go through the data more closely, but it sounds like you're in a hurry and just need a quick summary for the lab meeting.
Right. And see, it looks like the burn causes the sensitivity to decrease, and so does the infection. And the burn plus infection is even lower.
Right, but remember that the interaction effect is looking at whether those differences just add up to result in the effect of the combined treatment. If we look at the effect of burn, it decreased sensitivity by about zero point 0.1 nanograms, the infection by about zero point 0.2 nanograms, and the burn and infection by about zero point 0.3 nanograms. So in this case, there is a significant effect of burn, a significant effect of infection, but no significant interaction effect.
So that means.
There is no evidence from your data that the polytrauma model is any different than what you would expect from the two injuries separately.
Ugh, that's not what we were hoping for. What if we just added a few more animals?
That's probably not a good idea statistically, but we can talk about that another day. But another thing to note is the power calculations for two-way ANOVAs are a little different than power calculations for just two groups. So it's important to do a power analysis before you start a factorial design like this.
Ugh, I'm just tired of having failed experiments.
It didn't fail. Null results happen, a lot of the time. Just remember, a well-conducted study with null findings is more scientifically meaningful than a poorly conducted study with cool results.
Yeah, well, try telling that to my PI.
Touche. I'd be happy to if you need me to, but in the interim, good luck.